Have you ever wondered why there are holes in the prongs of power plugs? Well, let's find out. I wasn't very happy with the answer Technology Connections gave, so this is my version of that. I did also cover this in a earlier video, but let's do it again, because I've got something exciting. Look at this. This is a fresh slab of grounded duplex outlets, and we're going to take one apart and have a look inside it. It's a fairly recent model, well, sort of recent, 2021 4th month. You get cover plates like this for it. The standard Japanese stuff, that's an old one there in 2019. There's the ungrounded version, and you can get one with 3 outlets on it. Same plates are used for the switches and other modular things. Very similar to this much older National high angle outlet that we looked at in the earlier video. So the module that goes in there, or you can get it as one. These give a very positive feel when you connect them, and it's quite hard to remove the connector. So once it gets past a point, it slips in and locks into place, and then it's quite difficult to remove. As long as the plug is in spec with the holes in the right place. And so if we look inside one of these, we'll find on the terminals there is a little dimple. So that lines up and locks into the hole on the plug prong. That's why you get resistance to removing the plug, because it's being held in by that little dimple which needs to lift up and release its grip on the prong. That system of using the holes to lock the connector in place doesn't seem to be very common in the US style of outlets like this one here. It's just mush the whole way. There's nothing gripping it. Unlike these Japanese versions, these ones are made by Panasonic. There's definitely something in there. So I'm going to take apart the newest one and we'll see what we can find. Comes off pretty easily. It's all held in by these little crimps. So it's remarkably similar to what you see on these sockets, which come from the manufactured between I think the 50s to the 70s. Pretty much exactly the same. Probably this socket would mount in this. It's the same system, but it's slightly narrower now. Although there are wider versions of these, especially for the 200 volt outlets, you can get them in a wider version, so they have a wider gap. But the standard ones like this, they are slightly narrower than the equivalent US version, so the faceplates have to be different. But otherwise the back box mounting centers and type of screws used are all the same, which seems to be internationally similar mounting holes, mounting centers and screw types, except for Europe, which use those weird square outlets instead of these rectangular shape. Well, for their singles at least, and light switches. So what have we got in here? We've got what looks like some dimples on that side, only on one side, and then that there. I think that textured surface is where the cable connects. Yes, I think so. That's what the cable gets, what the conductor gets pushed against, that slightly textured surface. Yeah, so there we go. There's the answer. So the reason why there are holes in the prongs on the power connectors is so that they can lock into outlets. This one's a lot less pronounced. Still does it. It's a pretty complicated piece of metalwork to manufacture. It's probably done in one pass or two, punched out of a sheet and then folded in one go. You can see a little bit of a dimple there. Interesting that it's a lot less than this older version. It's interesting that there are different standards of measuring the size of conductors depending on where you are in the world. The Japanese approach seems to be to measure the diameter of the conductor. On the back of these it will say you can use diameter 1.6 millimeters or 2 millimeters, copper only, and you strip it. So you use that gauge there to know that you've stripped the cable to the right length, and then all you have to do is shove it in these holes. I think they're stripped for light switches at the moment. Oh, hang on, I misread that. It doesn't say 42, it says 12 millimeters. I wonder, that seemed a bit weird. Yeah, you strip it to 12 millimeters. 40 millimeters would be way out there. Whereas on the light switches, you strip it to 10 millimeters. And similarly, these will take 1.6 or 2 millimeter diameter cable. And these are rated at 300 volts AC, 16 amps. So they're quite good switches. So what we want to do is see what happens when we poke it in the holes. So there are the holes, you get two of them, so you can loop out to other outlets. And there's the ground and the W for the neutral, which has the wider slot. I don't know if we can see this. See the other one better. Oh yes, there's the wire that got pushed in. The conductor that got pushed in. So it comes up against that textured surface, and then that won't pull out because of the shape of the metal in there that's holding it. Ground ones looks like it's made by brass, made with brass, but the phase and neutral, they look like it's probably copper plated brass, something like that. So to release these, you push your screwdriver into the slots and that releases the clamp, and then the wires can slide out. And the way that works is a spring. So when you're pushing the conductor in, you're pushing it against that spring there, that sharp edge, and that's what prevents it from being pulled out. You can see it's put a little notch in there. So the harder you try and pull it out, the harder that sharp edge there is going to bite against the copper and prevent it from sliding out, and the harder it's going to push it against the other side there. So presumably they've done lots of testing on these and ensure that that is pressing the conductor hard enough against the terminal, enough that it can carry a full circuit load in one and out the other without giving too much voltage drop and without heating this up too much. Not sure if you're supposed to replace these after a certain amount of time once this spring weakens. Presumably that will happen. Same way that if your outlets use screw terminals, then you need to open them up every 10 years or so and tighten them up. Otherwise the wires will just fall off and catch on fire when you put a heavy load on them. Well, they'll loosen off and yeah, start producing a lot of heat. That's why they have things like EICR, whatever it's called in England, to get your electrical system tested every 10 years to make sure it's still in good functioning order. Now similarly on these they have the stab-ins, and presumably that works in the same manner. Looks like it wouldn't work with this thicker cable unless that little plastic opening just pushes open a bit more. I've not tried to use this one before. Presumably you can release it in the same manner. Yes, it releases when you bend that over a bit. Yeah, I always thought that this system here is extremely dodgy because when you do up the cable around these screws, loop it around the screw, do up the screw, and then you've got to force this thick, stiff cable to fold up as you push the outlet plate back in the wall, and depending on which direction it's folding, it could pop that screw open again. That's what it feels like to me. I don't know how often that actually happens. Whereas this system here, where inside you poke the wire in the hole, and then inside you have a rising clamp style terminal there. They're backed off and locked in position when you buy them, and then that tightens up and that will very securely clamp the wires, and are pressed against that rough surface, also that little dot thing presumably. And because they're pushed in straight like that and done up tight, they don't have that risk of twisting the screw open when you push it back into the wall. Yeah, copper is pretty soft material, so it will squidge out over time because of the pressure applied to it. It will conform, migrate. So you got to check these things. Okay, I think we rambled on for long enough, did we? What are the holes in the plug prongs for? For locking it into the socket. Although that only seems to apply in Japan mainly. Let's take a look at this one as well. This one's interesting. Got, hopefully, the right thing to open it. These weird triangle shaped ones, I don't know what that's for. Yeah, perfect. This has a really neat shutter on it which prevents you from accidentally plugging in off to one side. It will only open when you're pushing both doors open at the same time. Oh, look at that. So the conductors from the cable are crimped into position. There's white stuff around it, and then we can see there is an indent there on one side, and that will be providing the locking. This one does feel like a good lock. Yeah, so that's good because it's been pushed further on the inner side, so it's making a sharper point to prevent you from releasing it, but it makes a ramp on the other side, so that when you're pushing it in, it will slide in easily until you get past and that back edge locks into the hole. I think they made a mistake in this outlet and put that around the wrong way. Good Panasonic cable. So I think that's messed up here. Oh no, it is offset slightly, so the deeper edge has got a sharper edge on its hole, but they haven't punched that as hard, so that the dent on the inside of the terminal was a lot less. And I was wondering if we should take apart that older one wherever it went. Okay, I was looking for what happened to the older one of these that I was holding a short time ago. It seems to have vanished. Oh, it's here. Okay, it was just upside down. Should we take this one apart as well and see if the indents are any different? doesn't feel any stronger, so maybe not. Okay, so they print manufacturing dates on it. On the box here that they came in, there's the part number, 10 in a box, 21, 4th month, 15th day, which is pretty similar to what's exactly the same as what it says on the parts that are in the box. So do these old ones here, what is the manufacturing date of these? Because it doesn't appear to be printed on the unit, but it is printed on the box. There's the part number, WF1001. Pretty sure these will be 1002 for 2 outlets in one, and there's also a 3 version which has 3 outlets. Anyway, here's the box that the outlets come in, and it does have a date on it. So that would be 1970, presumably. That's what I imagine that would be. I'm not sure what the rest of the numbers are then. 9th month, 19th day maybe. And then the switches, light switches, that's got 80, 62, so 1980 perhaps? Maybe that's not right, because yeah, I thought they stopped manufacturing these in the early 70s. Not sure about that. The grid plates that they go with, that doesn't appear to have any dates on it. Oh no, look, it does there. 8023. Probably 1980. Anyway, there you go. The other thing that we touched on in a previous video is that you can identify which side of this is neutral and should be plugged into the wider slot by looking for the ridge on the cable. There's a very faint ridge molded into the cable, and that always goes to the neutral, the wider slot. So you can tell by feeling for that you should plug it in around that way, with the ridge going into the wider slot. It's always something like that on this US style, the polarized one with the wider neutral. Again, that has a ridge on that conductor to indicate that it's the neutral. And again on this one here, there's a couple of ridges on that side and it's smooth on the other side. And this one, this nice one off of that vintage flip clock that we looked at previously, that also has a ridge there, even though that doesn't actually matter. Yeah, so sorry about these kind of low budget videos, but there's been some other things going on that are taking up my time. But hopefully soon we'll take a look at the wonderful world of SVHSC. By taking this camera apart and seeing what's going on inside it. It's pretty fancy hi-fi stereo flying erase head SVHSC. Got more buttons and controls than you can shake a stick at. On every side of it there are more controls. Even under the battery of all places there's more things you can do. So we'll look forward to taking this apart and seeing what the deal is. Even more stuff under a flap. Who would have known? Yeah, we'll test this out, take it apart, see what the deal is. Tracking on the bottom there. And then we'll also go back to looking at the VHS cameras. And then we got tons, literally tons of VCRs to go through. At least 100 different models of VCR to take a look inside. So that's going to be exciting. And probably take years to get through. Anyway, now you know what the holes are for, undisputably.